In order to study the concept of IBS, one needs to focus on a particular project and, as the project progresses, look into each process. The most widely used and common IBS technique in Malaysia is precast concrete framing. It is visible in the construction of Akademi Binaan Malaysia Utara (ABMU) workshop building in Mukim Sintok, Kedah. The main contractor for the project is Yayasan Islam Kedah or YIKED, while the contractor for precast works is Associated Structural Concrete Sendirian Berhad, a wholly owned subsidiary of ACP Industries Berhad. The precast elements of the construction involves two parts, namely production of precast components in the factory and installation at site. Typical of any IBS project, the precast components are fabricated at another location before being delivered and assembled at the site. For the workshop buildings project of ABMU, the production of precast components was done in the Gurun plant and was supplied to the site at Sintok. Precast components are transported to the site from the plant using a 40-foot trailer. Timber stacking bearers are provided to minimize stress on precast materials during transportation. The materials are lifted and stacked using lifters. At the site, a mobile crane is used to unload the precast components from the trailer. The lifting and handling of each individual precast component is done through four-legged slings, with each leg of the sling possessing a capacity of 1 ton. To reinforce its strength, self-locking hooks or hooks with safety latches are used with the lifting slings. Upon unloading from the trailers, the precast components are placed as close as possible to each installation location. The most important part of an IBS project is certainly the installation process. Precast components at the site are then fitted and placed at locations indicated in the workshop drawings. Each component is then adjusted to perfection while maintaining its correct position. This IBS project follows an 8-step construction method. Step 1 consists of the construction of the workshop's foundation and ground beams. For this project, the foundation and ground beams are made the conventional way. Concrete was poured in situ. The next step involves the installation of the columns. Precast columns are placed in position and propped. These columns are produced using steel molds at the factory and delivered to the site for installation. The ground slabs were made in the next step. The slabs are cast at the site. Beams are also made in the same manner as the columns. Concrete is poured into casts, complete with steel reinforcement. The concrete is left to set and the casts are taken off. For ABMU, a few types of beams are made according to the building's drawings. Among them are first floor beams and roof beams. Notches and plugs are designed to lock the beams to columns. In step 4, the completed beams were placed in the respective positions, reinforced and propped. 5 involves the installation of half slabs that were made at the factory through a few special processes. At the site, half slabs were lifted into position and carefully aligned. For this project, props were arranged at the center of the half slab. Half slabs can also be designed without props. The frame or the structure of the building was considered complete once the foundation, ground slabs, columns, beams and half slabs were in place. With the structure completed, the next step was the laying of M&E services. All pipes and conduits for the M&E services were laid in position. In step 7, the half slabs, which were now in position, were applied with concrete topping. The last process of the precast method of construction for the workshop building is the installation of the fast walls. Fast walls are made light yet sturdy. Its production process is the easiest compared to making beams and columns. Fast walls are mass-produced in the factory as they come in 2 standard sizes and can be used in any precast project. The fast walls are light due to the cavities in its structure. The holes also give better insulation. As they are light, the fast walls are easy to handle at the site. Fast walls are placed according to the building's drawings. The groove on the fast wall will lock it in its place before being concreted. Steps 1 to 8 are repeated in cycles until all the building construction is complete. With the completion of the fast wall installation process, the IBS concept of the construction is concluded. Other construction aspects of the building will then be done the conventional way. With the case study and progress report of the workshop building at Academy Binaan Malaysia Utara, we clearly see how IBS has simplified the construction process. Production time is cut down and the site requires less manpower.